Hello, dear friends. My name is Dina Tendyk. I'm a math teacher. Welcome to our algebra and introduction of the analysis lesson. Today's topic: application of operation on complex number of algebraic form. After this lesson, you will be able to apply the arithmetic operation on algebraic complex number, apply the regularity of the value of the complex number in the exponential of complex number of the algebraic form. You will be able to find the square root of complex numbers. Recall that expression in the simplest form cannot have the square root in the denominator because the imaginary unit represents a square root. You must rationalize a denominator that contains the imaginary unit. To do this, multiply the numerator and denominator by the complex conjugate of the denominators. Okay, this is the real axis correspond to the x-axis, and imagine that the x-axis correspond to y-axis. Yes, think of a plus bi as x plus y. First example, let's graph the complex numbers. Graph each complex number like, first of all, we have the 2 minus 3i, minus 1 plus 4i, 4 plus I, and the last one minus I. Please, on the coordinate plane, you must graph the complex numbers. Before this example, I want to show how we can graph the complex numbers. First of all, I have the graph of each complex number like 3 plus 0i, 2i, minus 2 minus I, 3 plus 2i. Yes, recall the absolute value of the real numbers and its distance. Yes, for the solving the complex number, first of all, you can remember the vectors. Yes, do you remember how we can find the length of the vector? The absolute value of the complex number, yes, is a distance from an origin to the point AB. In the complex plane, will be that we can denote it like module A and B. It means we can find the like in root a squared plus b squared. Yes, second example, let's determine the absolute value for the complex number. Let's find each absolute value. First of all, I have the 3 in the model 3 plus 5i, b we have the minus 13, and the c I have the minus 7i. Okay, now we have the solution like the solution of the first will be the in root. Let's again remember the how we can find the length of the vectors. Yes, vectors in the 2-dimension. This is the also you can use for the vectors in the 3-dimension. Yes, will be the in root 3 square plus 5 square will be the in root 9 plus 25 will be the in root 34. It means the absolute value for the in model 3 plus 5i will be the in root 34. Let's talk about the b will be the here the in the model we have the like 13. We should imagine that we have the like minus 13 plus 0i. Yes, then we have the in root minus 13 squared plus 0. Now we have the like in root 169 will be the just 13, and the last one minus 7i. Minus 7i also we can imagine that we have the 0 will be the in module 0 plus minus 7i will be the 0 square plus minus 7 square, all of them in the root will be the minus in root 79 will be the just 7. And let's talk about the operation for the complex number, like adding and the subtracting of the complex number is similar to the adding and the subtracting variable expression with the like terms. Yes, do you remember that from the 7th grade, 8th grade, yes, or in the polynomial, we must find the like terms also for the complex numbers. Simplifying, to the simplify, we must combine the real parts and combine the imaginary parts. The set of the complex number has all the property for the set of the real numbers, so we can use the commutative, associative, and distributive property for the simplifying the complex number expression. And the last one, we have the tasks. For this task, the letter I denotes the imaginary unit that I is equal to in root minus 1. For the each integer k from the 0 to the 8, write the I in the power of k in the form of a plus bi. The B describe the pattern for the pattern you observe. The algebraically prove your observation. In particular, simplifying like I in the power of 195. The last one, the write each of the following expression in the form of a plus bi. Thank you for the lesson. Goodbye. See you soon.